Hi students, in this class we are all study about the molecular orbital theory applied to molecules nitrogen and oxygen. First we study about the nitrogen molecule N2. The atomic number of nitrogen is 7 and its electronic configuration is 1s2, 2s2, 2px1, 2py1 and 2pz1. The outer shell or valence atomic orbitals, that is 2s and 2p, in each nitrogen atom combine to form the following 8 molecular orbitals. So overlap of first one is 2s and 2s gives sigma 2s and sigma star 2s molecular orbital. Second one is 2px and 2px gives sigma 2px and sigma star 2px molecular orbital. Third one is 2py and 2py gives pi 2py and pi star 2py molecular orbital. Fourth one is 2pz and 2pz gives pi 2pz and pi star 2pz molecular orbital. So each nitrogen atom has 5 electrons in the valence shell. Hence in nitrogen molecule N2 there are 10 electrons. These electrons are to be accommodated in the above 8 molecular orbitals. 4 electrons will enter low energy sigma 2s and sigma star 2s molecular orbitals. The remaining 6 electrons will enter the sigma 2px, pi 2py and pi 2pz molecular orbitals, which are lying at the next higher energy level as in the energy level diagram. This figure shows the molecular orbital diagram of nitrogen molecule. The electronic configuration of nitrogen molecule is 2n, 1s2, 2s2, 2p3 gives n2, kk, sigma 2s square, sigma star 2s square, sigma 2px square, pi 2py square, pi 2pz square. Here kk represents completely filled inner shells which do not take part in the molecular orbital formation. The bond order of the molecule is 8 minus 2 divided by 2 equal to 3. Out of this, one is a sigma bond and the remaining 2 are pi bonds. So out of 10 electrons, 8 electrons occupy the bonding orbitals. This makes the nitrogen molecule a highly stable molecule with a high bond energy of 942 kJ per mole. So nitrogen molecule is experimentally found to be diamagnetic. This is due to the absence of odd electrons in any one of the molecular orbitals, that is all electrons are paired. Next is the oxygen molecule O2. The atomic number of oxygen is 8 and its electronic configuration is 1s2, 2s2, 2px2, 2py1, 2pz1. The outer valence shell atomic orbitals, that is 2s and 2p in each oxygen atom, combine to form a total of 8 molecular orbitals. Each oxygen atom has 6 valence electrons. Hence, in oxygen molecule O2, 12 electrons are to be accommodated in the 8 molecular orbital that are formed. 4 electrons will enter sigma 2s and sigma star 2s molecular orbital. 6 electrons will enter sigma 2px, pi 2py and pi 2pz molecular orbitals. The remaining 2 electrons will occupy pi star 2py and pi star 2pz. That is, 1 electron will go to each of the antibonding orbitals, as these orbitals are of same energy to give 2 unpaired electrons. The distribution of electrons in various molecular orbitals is given in this figure, and the electronic configuration of O2 molecule is 2O, 1s2, 2s2, 2p4 gives O2, kk, sigma 2a square, sigma star 2a square, sigma 2px square, pi 2py square, pi 2pz square, pi star 2py1, pi star 2pz1. So the bond order is 8 minus 4 divided by 2 equal to 2. The 2 oxygen atoms are bonded by a double bond. This double bond consists of 1 sigma bond and 1 pi bond. The formation of these bonds is explained as follows. 2 electrons in the sigma 2s and 2 electrons in the sigma star 2s cancel each other. 2 electrons in the sigma 2px will form a sigma bond. Out of 4 electrons in the pi bonding orbitals, 2 electrons are cancelled by the 2 electrons in the pi anti-bonding orbitals. Hence, 2 pi electrons form a pi bond. And comparison of the molecular orbitals of oxygen molecule with nitrogen molecule reveals that oxygen molecule has more number of antibonding, that is 4 electrons, than nitrogen molecule contains 2 electrons. So hence oxygen is less stable than nitrogen with low bond energy of 494 kJ per mole. Various experiments show that oxygen molecule is paramagnetic, having one or more odd electrons, and molecular orbital theory clearly indicates the presence of 2 unpaired electrons as pi star 2py1 and pi star 2pz1. Okay students, in this class we are all study about the molecular orbital theory applied to molecules nitrogen and oxygen. Okay students, thank you.